This video will help you solve, graph, and check one-step inequalities. So solve each inequality algebraically, graph the solution on the number line, check your solution. So looking at our first example, we have x plus 4 is greater than negative 3. So on the same side as x is the value 4, it's attached by addition. So our first inverse would be to subtract 4. On the left side we get x. Keep our inequality symbol the same, and negative 3 minus 4 becomes negative 7. So on my graph, I put negative 7 in the middle. Go two values either side of it. Open at negative 7, and I'm graphing numbers greater than negative 7, so I would shade towards the right. For my check, I can pick any number above negative 7. I'm going to use 0 because typically 0 will be a nice number if it's in your shaded region to check with. So if x equals 0, going back to the original, it would be 0 plus 4 is greater than negative 3. And then when I simplify each side, 0 plus 4 is 4. That is greater than 3, so it checks out okay. Looking at our next example, 8 is less than w minus 3. On the same side as w is the number 3 is attached by subtraction. So my inverse would be to add 3 to each side. 8 plus 3 gives me 11 is less than w. Before I graph, I like to rewrite it with the w written first. So that's the same thing as saying w is greater than 11. So on my number line, I put 11 in the middle. It's open at 11, shade towards the right. So now picking some number above 11, I'm going to use 20. So w equals 20. Going back to my original, 8 is less than 20 minus 3. And now when I simplify it, 20 minus 3 is 17. 8 is less than 17, so it checks out okay. Negative 4 is greater than or equal to 5y. Attached to y is 5 by multiplication, so my inverse would be to divide each side by 5. So I get negative 4/5 is greater than or equal to y, but I would rewrite it with the graph y written first, so that's the same thing as saying y is less than or equal to negative 4/5. So on my graph, I put negative 4/5 in the middle. Because of the equal sign, I would have a closed point at negative 4/5, and I would shade towards the left. So for my check, I'm going to look and see what happens if y is negative 1. I have negative 4 is greater than or equal to 5 times negative 1. And then when I simplify it, 5 times negative 1 would be negative 5. That is a true statement. Looking at our next example, 6 is less than negative 3r. Attached to r is negative 3 by multiplication. So my inverse would be to divide each side by a negative 3. And remember, if you multiply or divide by a negative, you have to reverse your inequality sign. So 6 divided by negative 3 becomes negative 2. Change my inequality sign to greater than. And on the right side, I have the value r. Again, I'd like to rewrite it with the r written first, so that's the same thing as saying r is less than negative 2. So I put that on my number line. Open at negative 2, shade to the left. So for my check, I'm going to use r is negative 10. Going back to my original, 6 is less than negative 3 times negative 10. And negative 3 times negative 10 is positive 30. 6 is less than 30, so it checks out okay. Hope this video helps. Let me know if you have any questions. Thanks.